This video covers how to do looping in R. So this section of the course is really about how to improve your programs. And what we mean by improve your programs is sort of improving the efficiency of how you're writing the program. So for instance, there may be a certain section of code that you need to repeat maybe 4, 5, 10 times where you're only changing a variable each time. So maybe you're finding the summary measure for one column, and then you're doing it for the next column and then the next column. So you can think about writing that same code 4 times, or we can talk about what's called looping, and later on vectorized functions to do that kind of thing. And then what we're going to talk about after that is really what would make you have a really firm understanding of how R works, and that's how to write your own custom functions. Once you can write your own functions, it really opens up everything that you can do in R. So there are a few ways to do loops in R. So again, looping is the idea that I'm going to repeatedly execute a section of code, and perhaps some things are going to change each time I do that, but for the most part, I'm running the same chunk of code over and over again with some moderate changes. And so we'll look at for loops extensively in this video for how to do looping. And there's also while loops and repeat. So those are other ones. We'll briefly mention while, and you can read about repeat if you're interested in that. So with for loops, here's the syntax for them. This is sort of the common way that we have syntax for R, right? We have our keyword here, like it was with an if statement. With if, it was a condition, and then curly brackets with the code to be run in between. So for is similar. We do for, we give it the index, the thing that's going to change each time in the loop, and then we say in whatever values that index should cycle through. And then within the curly brackets, we give it the code that should be executing each time the loop goes. Okay, so just to put those in words, index the counter or the variable that changes each time, and values define which values that index takes on. So a very basic example of a for loop here in R would just be for I in 1 to 10, print I. And so I is going to start at the first value here, which is 1. And then it's going to execute that code with 1. And then it's going to come back to the top. I is going to go to 2, execute that code, come back up top. I will switch to 3, et cetera, et cetera. And remember here that 1:10 creates a vector 1, 2, 3, 4, 5 up to 10. So I is iterating through each one of the values that you see on the right. And those values on the right don't need to be numeric. So for instance here, my thing that's changing here is going to be index, and it can go through these 3 values that you see: cat, heart, hat, and worm. So the first time we go through this loop, index takes on the value cat, come back up to the top, takes on the value hat, come back up to the top, takes on the value worm. And so just to give you an example of something silly that you might want to do, perhaps I have some data and I want to cycle through and print out something for each one of those data points. So I'm going to create a words vector that corresponds to first, second, third, fourth, and fifth. And then I'm just going to get 5 random data points. So I'm using runif to get 5 random numbers between 0 and 1. And so what I want to do is I want to loop through each one of these observations, and I want to print out the phrase, the first data point is the first value from the vector, for instance. The second data point is the second value. And so again, you could just think about writing 5 lines of code that looks something like what you see here. Paste 0, grab the first thing from the words vector, data point is, grab the first thing from the data vector. And that would work fine, but again, you have to put in that same line of code 5 times, and you just have to go through and change the value that you're indexing at. Rather than do that, we can utilize a for loop. So now we're going to let I go from 1 to 5, and then we're going to print the pasted out string that you see here. And so notice that we've changed the thing that we're indexing by to I. Right? So the first time this runs, I is 1, goes through and prints that out, then comes back up to the top, I is 2, prints that out, and so on and so forth. All right, so let's do something a little bit more involved now. So one thing that often does come up is perhaps for each of my numeric columns of a data set, I want to find the summary statistics. So I want to find, say, the 5-number summary and the mean. We know that the summary function will do that for us. And so one thing you could consider doing is just doing a for loop that loops through each one of your numeric columns of a data set and runs the summary function on that particular column. And so we need a data set to do this kind of thing. So we're going to bring in the layman package, which has data set on baseball, if you recall. And we'll just consider the batting data set. And so what we're going to do, we're going to grab that batting table, we're going to convert it to a tibble, and then we're just going to select these columns that you see here. So player and team ID, both of those are categorical, not something that we would want the summary of. But then games, at bats, runs, hits, doubles, triples, and home runs, all of those are going to be numeric, and all of those columns would make sense to find summary measures for. So here's what that data set looks like. So our idea here will be, let's loop through. We'll start with this column, and we'll find the summary. Then this column, find the summary, all the way down to home runs. So how you would do it for just one column, this is one way to do it. You might just do new batting, grab the third column, and say just do the summary for that. Or you could do new batting, $G, and do the summary for that. Either way would be fine. And so here's how we could do it with a for loop if we wanted to. So now I'm saying for I in 3, because I'm going to start indexing there, so I want to start with the third column. So I might start with I in from 3 to, now this is getting me the dimensions of my batting data set. So dimensions of a matrix or data frame, right? The rows by columns. So dim of new batting is going to return a vector of 2 things. First one rows, second one columns. So I'm saying grab the second entry, which is the number of columns. So from 3 to the total number of columns, run through each time and print the summary of that batting data set, that particular column. And so you can see that this works just fine. Not ideal output, but we're essentially just printing here. Maybe we're just visually inspecting, making sure our data looks reasonable. One thing that you might want to do rather than use, say, 3 to the number of columns in our data set, there's this function called sequence along, and that just will essentially do what we're talking about there, creating a sequence that goes along, say, the matrix columns. So here we have 9 columns, so sequence along of new batting will create a sequence from 1 to 9. And so here I'm saying from I in the sequence along, but I don't want the first 2 because those represent the categorical columns, right? So I'm going to subtract 1 and 2 out of there. So I'm going to remove those 2. And so this is just going to now be a vector from 3 to 9. So just an alternative way to specify your values for your index to iterate over. Okay, so you hopefully have the basic idea for loops. Let's talk about some of the things that are useful to know to sort of kick out of a loop or to stop a loop or those kinds of things. The break function, or the break keyword here, will kick you out of a loop. So for instance, if we wrote this set of code, and now I have an if statement in here that says if my index is equal to 3, let's break, we'll kick out. And notice that since I've written the conditional, the code that will execute if the condition is true on the same line, I don't actually need curly brackets. But I could, if I wanted to be verbose, put a curly bracket here and a curly bracket here. Okay, but you can see here that once I reaches 3, it hits that, the condition resolves as true, and then break is executed, so it kicks us out of the loop. There's also the next next keyword, which will skip this iteration of the loop, or at this from this point forward, skip the iteration of the loop. So here, if I is 3, we're going to skip that iteration and jump back up to the top. And then the last thing I want to show you is just the basic syntax for a while loop. It's the same exact idea, except basically this will continue to execute until that condition becomes false, right? I'm sorry, well, until it becomes true. Wait, sorry. If condition is false, then the loop never executes. So yeah, so as soon as that condition becomes false, it will stop executing the loop. Sorry, brain fart. That's the same exact idea, right? We just have curly brackets in the expression that's going to be the code that's going to be executed within there. Okay, so hopefully for loops aren't too bad for you. They're one way to make your code more efficient, but one issue with loops in R is that they are not ideal. They are slower than other methods, and so we're going to talk about the idea of what's called a vectorized function in the next video, and those will be faster And so if possible, if you can utilize one of those, they are better than loops.